It will be very short. It's, as you see here, a half-baked teaser because I was working, was not really working, but collecting the input for this, like looking into what's the electronics inside the original QL, how everybody says, oh, it's maybe not done as it should have been, and so what's the reasons behind it, what's really in there. And I collected some input, and of course it's very much inspired by, sorry if this is hard to see here, it's very much inspired by Urs and by Nasta's input, because Urs has all the interviews with David Carlin, and Nasta has all the analysis of the, at least at the one ULA. So very quick, and it's just half-baked, so I tell something and we can discuss this evening. Maybe I get some more input from all of the expertise that's in the room. And maybe next year we have a proper presentation then, and it's only like 10 slides. The Frontula, that was the starting point. It was Sinclair's way to the success. So they had the ZX80, which was decent, but once they combined everything into this Ferranti ULA with the ZX81, this is an advertisement, sorry, cannot read it there, but they really said, oh yeah, we have this master chip now, and that's the best thing about our computers. And so the ULA was kind of, for Sinclair themselves, the way to the success. The ULA Ferranti was from the UK. It was used successfully in the ZX80 to replace stuff, and then in the Spectrum even, they used another ULA, and it was the big success for them commercially. And I kind of collected which devices they all used ULAs in. For the example, the ZX printer, it's very cheap, but it has, like the ULA, the mini television, the only chip inside is a ULA. The interface 2 has a ULA to expose the ROM to the Spectrum. The ZX microdrive, of course, has this ULA. Even the second version of the 16K RAM expansion of for the ZX81. The first one was very hard to manufacture. The second one was much easier with just one PCB, and it had a ULA. And even this infamous C5, like personal transportation car, in the head-up display, the display where you see how much power is left in the battery, it had a ULA. So maybe, so for Sinclair themselves, it was, oh yeah, we used
What does ULA mean?
Uncommitted logic array, sorry.
Okay.
I should have gone back to the basics. ULA means the Ferranti, they build a chip that's kind of generic. It has all the logic gates on there, but not the way how it's kind of linked together. So then the customer, like Sinclair, would go and say, I need some metal layer to connect all those cells in the chip, and this is what's the custom thing about this. So Ferranti had a chip, and you could then make another two masks and put them on top and say, okay, that's this chip, but it has a special connection mask on top of this. So it was kind of, I guess it takes like half a year or maybe 100,000 euro to get it started, but then you can just buy these ULAs from Ferranti and you have your special chip that nobody can easily copy. It's kind of the early version of the FPGA. FPGA you can program in the field, but ULA you had to have like manufacturing masks really. And that's one of the confusions here. So this Ferranti ULA, it was very successful in the ZX Spectrum. So what's next? Ferranti had another version of the ULA. We also know the 40 pins on this ULA was, if you want to run for a 16-bit computer, it's not big enough, you would have to have bigger chips. And the time when the QL was designed, already Acorn, which is another company in England, they tried this with the latest generation of this Ferranti ULA, and they ran into trouble. You see this chip on a Acorn Electron, which was supposed to be a low-cost computer for them, but it already looks quite expensive, and indeed it was. The technology was not there to have chips that were bigger than this 40 pin, and yeah, so Acon ran into trouble. The question was, what would the QL do then if the usual step to get from a ULA to a better ULA was not really there. The technology was at its limit. So what was really in there? Oh, one thing that you can already see from the if you look at the PCBs, the interface 1. So Sinclair always used Ferranti ULAs, but in the interface 1 there's already no Ferranti stuff inside. It's a general instrument stuff, and if you look up in like some old archives, it's very similar to ULA, but it's already CMOS, which has the power saving technology, and yeah, kind of the question would be, okay, they built in a ULA, they could have picked Ferranti, but they didn't. So why did they go to a different manufacturer? Probably because the ULA consumes too much power. And that was already visible. You cannot go far with a ULA, with a Ferranti ULA. They wanted to, they already replaced this with the interface 1, so it was not there really path to the future. So maybe that was the reason for the QL to not have just the ULA as previously from Ferranti. Funnily, the designer who made the interface 1, like controlling all the microdrive stuff and so on, was Martin Brennan, and he later on left Sinclair, didn't work on the QL, but went to work on the Jaguar, the Atari Jaguar.
And so the Flair company,
yeah.
Flair 1, Flair 2, Chapter.
So there Urs can say more about Jaguar. And so they lost all the expertise they already had on microdrives and so on before they designed the QL chips. In 1983, there was this, okay, we have 16 bits now, what do we do for the next generation of computers? So while Sinclair was always using this ULA and using their way to success is, if you look at the Apple Macintosh, it doesn't have any ULA, it doesn't even have any special chip. So it was made like very easily, like fast time to market. There's one special chip on this. This is the IWM, which is the so-called integrated WOTS machine. So Steve Wozniak was designing this, but this was already used for the Apple II. So they didn't make any special chip for the Apple Macintosh, and that's why they were able to bring it fast to the market, as fast as the QL. It was, I guess, introduced in the same week. So it was not obvious that you have to go for special chips inside your computer. Other companies didn't do this. The Amstrad CPC also very conservatively used some standard old chips there, nothing special. They had also a Ferranti ULA, but only for very special stuff. So now what should the QL designers have been done at this time? Of course, everybody knows they have the ZX8301 and the ZX8302, and if you look at this, they picked two different vendors for this, which is Plessey, which is one vendor from the UK, and NCR, which is a vendor from the US. And there are still Ferranti ICs in there, so they had three different vendors for different custom ICs in there, and if you know this, you have to have relationship to all those vendors, you have to have special design tools for every of those vendors, so it was really hard for Sinclair in a way to really design all this. Going for this master chip, and there, of course, we have NASDA's analysis of how does this work. You see those burst mode reads where it gets a lot of video data at one point, but at the same time you slow down the CPU quite a lot, so that's kind of what was already built into the ZX Spectrum ULA, and they just reused this for the QL. And for the Spectrum it was okay, because the Z80 was quite decent in speed. For the QL it was at the limit, you know, it's really slowing down the CPU there. Why is this chip from Plessey? We don't know. If you look at the data sheet from Plessey, they could also have picked just the Ferranti ULA again. So it's, I don't know, there must be something behind why they picked this new vendor for this. It's very similar, but yeah, again, in vendor, so there must have been some trouble there. The question is, why not 8 MHz CPU clock, avoiding this infamous two-white line? And yeah, Nasta looked into this. So there could be two reasons for this. That this chip they picked was only specified for 14 MHz, and we already have 15 MHz as an oscillator there. So they maybe already overclocked this and didn't want to overclock it further, or because of the price of the RAM, which is more expensive and it's faster and running with 8 MHz. The other chip, which I found very interesting, this is the 8302. If you look at this, and it's called QL Cyborg project, where I try to mimic what's inside this chip. It's not really much. There's a PLL for the microwave signal, which they already had in the interface 1, but just they had to re-implement this for a different vendor, which according to this interview with David Carlin was not so easy. They have this real-time clock, which is of questionable use because they don't have a battery backup for this, so it only survives pressing the reset button, but that's the only thing it really does. And there's a lot of hardware inside for this. It has this slow 1-bit interface to this IPC, which is also not much of use, which is like, looks like it's like provisional thing. It has the UART transmit data, which is okay, but it's not really very fancy hardware that you would not get somewhere else. Of course, it has this interrupt request and masking, but if you look at this, it was from NCR, and it's indeed, it's not a ULA, it's not a programmable thing, it's a custom IC, so ASIC, application-specific IC, which is a completely different story than using a ULA or different chip, because you go to a vendor and they design the whole chip for you. If it's wrong, they have to redo the chip, they have to do all the masks for this chip once again, which is 10 masks for different layers of this chip. I guess Stefan can tell much more about this. And it's a turnaround time of maybe 6 to 9 months. So if something's wrong with this chip, it would take Sinclair another half a year to bring this QL on the market. Why did they pick this? I don't really know, but there's some evidence that they picked exactly this ASIC technology for their chip there, which in the end, yeah, probably didn't gain them much. Why is there some evidence that they picked this NCR chip? If you look into this data sheet of this NCR ASIC handbook, they already say, hey, with our ASICs you can do 32 megahertz oscillators, for example, for your real-time clock. And this is what NCR says. And if you have this inside your chip, you have to do this outside. And if you look into the QL schematics, they exactly have this outside. So there's some evidence that they picked this ASIC technology exactly in this kind of data sheet for the 8302 special chip. So what might have been the idea for this? Because yeah, just for a real-time clock you don't need an expensive chip. The NCR would also offer to build other things on this chip. For example, like a sound generator, digital analog converter. So you could just have like digital sound, like in the Amiga, like synthesized sound and so on, just in this chip if they had built in this one. And it would be for the same price if they had the time to build it in. Even NCR offered to build in 6502 CPU inside, so maybe the original idea was instead of having this 8049 IPC to build something inside this chip, to have like a one very complex controller for all the peripherals. We don't know, but at least they must have had some initial thoughts that it would be much more powerful than how it ended up, because how it ended up, it was not much more than a ULA. So the open question for me, sorry, this is a bit too dark. So the ZX8301 is very similar to the Spectrum ULA. What if they designed it to match the 68008 natively? So this is what Nasta also thought about in his contributions there. Could the video and CPU timing have been better? Again, and was a full 16-bit, like 80,000, not 80,008, within reach at that time. So could they have designed it to build in a full, maybe like a Atari ST or Amiga processor inside? More interesting, I think, is also the 8203 as an ASIC, but that could have been much more powerful because they could have put much more stuff inside. It ended up at something which is on the interface 1 level for the Spectrum, which was not that powerful. So what was the original idea behind, and what about this 8049 IPC? Is it just a bug fix because they were not done with this chip, or was there some more plans behind? And already the next one. So great source for all this, of course, in further reading is the interview that Urs had with David Carlin, because you asked exactly the right questions. So why did you do this and why did you do this? And he also mentioned that the 8302 is an ASIC, and kind of you can read from it that he said, oh, I'm proud on the 8301. That already says maybe he's not so proud that the 8302 didn't get finished, I don't know. But that would be really between the lines of the interview, but the interview is already very interesting, I think. And so that's it for the short presentation. This is just some what I collected, so when looking into being interested in the QL. And yeah, so maybe in the evening we can discuss some of the details or yeah, ideas behind why this could have been done this way, and maybe next year I have a presentation that has all the input that I get this time. Thanks a lot.